Hi maths students, it's Mr. Hatchgasm, and today we're going to learn how to plot linear graphs using a table of values. Now the equation of a line is in the form of y is equal to mx plus c. So if I just get my annotations out here, if we have a look here, the equation of this line is y is equal to 2x minus 1. That's in the form of y is equal to mx plus c, where m is the gradient. So in this case, the gradient is 2, and minus 1 is the y-intercept. So that's the point at which our line intersects the y-axis. Now, I'm not going to talk too much about this during this lesson, but I think it's just something that we need to have in the back of our mind. So m is the gradient, so that's the change in y over the change in x. So from, let's say, point A to point B, or coordinates A to coordinates B, we're going 1 across along the x-axis and 2 up along the y-axis. So the gradient m is the change in y over change in x. So in this case, that's going to be 2 over 1, which is simply 2. Hence why we have 2x minus 1. All right, so let's have a look at what we need to know before we can plot linear graphs from a table of values. So here it says, work out the value of 3f plus 2g when f is 7 and g is 5. So this is substitution. We need to be very good at substituting values into equations and expressions. So if f is 7, what this will be is 3 times 7, and I'll write the 7 in brackets, plus 2 multiplied by g, which is 5. So that's going to be 21 plus 10, which will give us a value of 31. So it's very important that you can substitute values comfortably into equations and expressions. So let's move on to the next slide here. It says on the grid, draw the graph of y is equal to 4x minus 4 for the values of x from minus 2 to 3. Now, what this is telling us is we need to draw a table of values and find our y values when x is the values from minus 2 to 3. So what we need to do is draw a table of values here. Sometimes this is given to us in the question. Sometimes we need to draw the table of values. And what we want is when our input, so when our x value is minus 2, what is the output? Well, the output is going to be y. So x, we can think of x as the input and y as the output that we get. So what we need to do here is to substitute these x values into this equation. So let's have a go at this. Y is equal to 4. In place of x, I'm going to put minus 2, because that's the first x value that I need to find, that I need to insert or substitute into my equation, minus 4. So y is equal to 4 times minus 2 is minus 8, and then minus 4, well, that's going to give us a y value of minus 12. Minus 8 minus 4 is minus 12. So when x is minus 2, the output y is going to be minus 12. And we can plot that point or the coordinates. So we're going 2 across the x-axis, minus 2 across the x-axis, and minus 12 along the y-axis. So that's our first coordinate there, and I've just plotted it. And then our second coordinate then, so I'm just going to rub some of this out. So once again, now we want an x value of minus 1. So when x is minus 1, what do we get? Well, 4 times minus 1 is minus 4. And then we have minus 4 from the equation. So minus 4 minus 4, that gives us a y value of minus 8. So when x is minus 1, y is minus 8. And again, we go minus 1 across and minus 8. So this is our second coordinate. Now let's try the same with 0. So what do we get when x is 0? When x is 0, well, 4 times 0 is 0. 0 minus 4, well, that's simply minus 4. So when x is 0, y is minus 4. Now, hopefully you'll be able to see a pattern here. We're going up in 4s each time. And the reason why that is because we have a linear equation. So we said the equation of a linear line is y is equal to mx plus c. Therefore, this increase is going to be constant. So the next value, without doing any substitution, the next y value should be 0. And the one after that should be 4, and the one after that should be 8. Now I'm just going to test this out for 0 as well to see if this holds true. So we worked out the first three. So we said when x is 1, y should be 0. Let's see if that is true. 4 times 1 is 4, and 4 minus 4 is 0. So again, that is an increase of 4. So my advice to you is when you become really good at these problems where you have to draw a table of values, once you have maybe 3 y values, you rather than doing substitution, you can just go up in 4s. And if you really wanted to make sure you've done it right, you can then substitute the values again just to see if you've got the correct values. But so long as the increase is constant for a linear equation, that should be absolutely fine. And anything in the form of y is equal to mx plus c is a linear equation. And this is in the form of y is equal to mx plus c. All right, so here are our values. We just need to plot them on our graph. So 0 minus 4. So when x is 0, y is minus 4. That's going to be this point here. And what's interesting is we said minus 4 is the y-intercept. And that's the point at which we intersect the y-axis, and that's the point at which x is 0. And as we can see here, our y-intercept is at minus 4. And then when x is 1, y is 0. And when x is 2, y is 4. And when x is 3, y is 8. We've plotted the points for the values between minus 2 to 3, and now all we need to do is draw a line through these coordinates. So use a ruler, and this is what your line will look like. And that's the equation of the line y is equal to 4x minus 4. And that's absolutely right, because the y-intercept is minus 4, and we can quickly check the gradient out. So we said the gradient is the change in y over the change in x. And if I just erase this, so we said the gradient is the change in y. So m being the gradient is the change in y over the change in x. Well, let's pick 2 points. So I'm going to pick this point here and this point here. We are going and maybe I'll use a different color. Even though we're going 2 squares across, each square is 0.5, so that's a change of +1. However, in this case, along the y-axis, each square counts for 2. So we are going 2, 4 up. So the change in y is 4, and the change in x is 1. And 4 over 1, well, that's simply 4. So our gradient is 4, and our y-intercept is minus 4. So this is the correct equation of this line. All right, let's do one more example. So here it says, on the grid, draw the graph of x plus y is equal to 4 for the values from -1 to 5. So again, sometimes in a question, the table of values is given to you. Sometimes you might have to draw it yourself. So in this case, I'm going to draw it myself, or I should say animate it myself. And now what I need to do again is to substitute the values in. Now I have a slight problem here because the equation of this line is not in the form of y is equal to mx plus c. So it would be a lot easier if we rewrite this in the form of y is equal to mx plus c. So in other words, we need to make y the subject here. So x plus y is equal to 4. To make y the subject, I have to subtract x from both sides. So x minus x, well, they cancel out, that's 0. So we get y is equal to 4 minus x. So now I've made y the subject, it's going to be a lot easier to work out the value of y when we have different x values. So I'm just going to rewrite this as y is equal to 4 minus x. So this equation is just this equation written in a different way. All right, so now that I've done this, I can start substituting some values, and I'm going to use my black pen again. Here we go. So when x is minus 1, what is y? So y is equal to 4 minus x. So that's going to be minus 1. Now notice here I've written minus 1 because the x value is minus 1. So you need to be really careful here. So keep that minus, it's going to be 4 minus, in brackets, your x value, which in this case is minus 1. So what we get is y is equal to, well, 4 minus 1, these two become a plus. So that's going to be 4 plus 1. So y is equal to 5. So when x is minus 1, y is equal to 5. So that's our first coordinate there. Now for 0, if I just get my rubber. So again, we need to do some substitution here. So 4 minus 0 in place of x. So 4 minus 0, well, that's simply 4. So when x is 0, y is going to be 4. So when x is 0, y is going to be 4. And then if I rub these out again, once again, we said y is equal to 4 minus x. So 4 minus 1. Well, 4 minus 1, that gives us a y value of 3. So when x is 1, y is 3. And hopefully, again, you should be able to notice the pattern that we have. So here our pattern is going up. So rather than going up, I should say we are going down by 1 each time. So we are subtracting 1 each time. Therefore, the next y coordinate should be 2, and I can just test that out. So I've got 4 minus, when x is 2, well, 4 minus 2, that gives us a y value of 2. So as we said, our y coordinate is 2. And likewise here then, our next y coordinate is going to be 1, the next y coordinate is going to be 0, and the next y coordinate is going to be minus 1. And now we just need to plot these points onto our grid. And I'm just going to test this out for 4 as well. So when x is 4, we can see, if I can just use my eraser. So 4 minus, when x is 4, 4 minus 4, well, that gives us a y value of 0. So this is correct, and I'm just going to plot the remaining coordinates. So I have 2, 2. And then I have 3, 1. So 3 along, 3 across, 1 up. And then 4, 0. So when x is 4, y is 0. And 5 minus 1. And then what I need to do is just join these points up using a ruler. And here's the equation of my line. So this is the equation of the line x plus y is equal to 4, or y is equal to 4 minus x. Now notice one thing here. I've not quite written this in the form of y is equal to mx plus c. So if I just rub some of my workings out here to give me more space, I've written it as y, so y is equal to mx plus c, where m is the gradient and c is the y-intercept. So this, we just need to rewrite it. I've written it as y is equal to 4 minus x, but I could rewrite it as y is equal to minus x plus 4. Now it's in the form of mx plus c. So my y-intercept is positive 4, and we can see that over here. We intersect the x-axis at positive 4, and the gradient is minus x. Well, minus x just means minus 1x, and usually in algebra we don't write the coefficient of x if it's 1. So because we have minus x, that means our gradient is actually minus 1, and we can test that out. So let's pick two coordinates. I'm going to pick this coordinate here and this coordinate here. So we are going down by 1, and again, be mindful the two squares count for a half each. So that's going down by 1 and across by 1 as well. So we said the gradient, we said m is the change in y over the change in x. Therefore, the change in y is minus 1. The change in x is plus 1. So that gives us a gradient of minus 1. Minus 1 divided by plus 1 is just minus 1. And that's our final answer for the gradient. So the gradient is minus 1. Therefore, the equation of this line is y is equal to minus x plus 4 in the form of y is equal to mx plus c. But again, we can rewrite this as, if I was to rearrange this, as y plus x is equal to 4. So be mindful, if they give you an equation of a line that's not quite in the form of y is equal to mx plus c, it's important that you know and recognize where the y-intercept is, what the gradient is, and how you can rearrange this in the form of mx plus c. Right, I hope you found this lesson useful. That is the end of our lesson, and all the best. Bye.